Hello everyone. So today we're going to start section 7.2, which is basically applications of the normal distribution. So what are we going to do here is we are going to find the area under the normal curve, but this time it is not the area in one side or the other side. The area could start from anywhere and end at anywhere else. So basically we are finding the area of a random part of this normal distribution curve. Okay, so first thing is, let's start with the regular normal distribution curve. So what is a normal distribution? Just to remind you guys, we have been doing this for the last couple of classes, and also we have done this in chapter 3 before, chapter 3 or 4. I'm not exactly sure about that, but you have been watching this normal distribution for a while. So let's talk about the normal distribution we have seen so far. I'm drawing the normal distribution over here. So this is the regular normal distribution. So regular normal distribution means this is a bell curve, and the mean is in the middle, which is mu, right? And this is the x-axis. So this is the regular normal distribution. But in this chapter section 7.2, we are going to convert the regular normal distribution to the standard normal distribution, which is this. What is the reason behind that? Because standard normal distribution is easy to work with, and this one is kind of a role model for all normal distributions. So that's why we convert any normal distribution like this to the standard normal distribution like that. Okay, now the conversion is really simple. We have to use a simple formula, and that actually converts any normal distribution to standard normal distribution. So let's talk about that formula. So the conversion formula is z equals to x minus mu over sigma. Okay, when we use this formula, the simple conversion formula, any normal distribution basically converts to the standard normal distribution. Now, what are the differences between those? Look at that. The standard normal distribution has mean 0 and standard deviation 1. That is always true. When you make the conversion, the mean should be always 0 and the standard deviation should be always 1. And the other difference is the x-axis is no longer an x-axis. This is going to be the z-axis, and more specifically, this is basically the z-scores. Okay, all right, so let's move forward. What I have shown you in the last slide is written here, so let's talk about that. The definition of standard normal distribution. Suppose that the random variable x is normally distributed with any mean mu and any standard deviation sigma, right? Then when we use the conversion formula, z equals to x minus mu over sigma, that will be called the standard normal distribution, right? So when you convert that using this conversion formula, what happens is that will also be normally distributed, but this time the mean converted to 0 and the standard deviation converts to 1. Okay, and the random variable z is said to have the standard normal distribution. All right, so long story short is we actually convert the regular normal distribution. So I'm going to write regular. So regular normal distribution. I'm just writing dist. And we convert that to standard normal distribution. Standard normal distribution by using the conversion formula z equals to x minus mu over sigma. Okay. Move forward. So this is called the standard normal distribution table. So this is basically came from your book. You can check your ebook, and this is table number 5. So this table is very important for you from now on. So this is kind of a milestone for you, and you are going to use this table over and over again, at least for the next 2 sections or next 1 section. Now, what is this table actually? So this table is actually some pre-founded values are there in the table. So we are going to use those values to solve problems, okay? Now, let's look at the table here. So let's zoom in. So look at that. This is the column called Z, right? So through the column, this is the Z scores. Let's look at the first column only. So the column and the first row is for Z scores, okay? And the body of the table are basically areas. So the body of the table are areas to the left of that given Z score, okay? We are going to solve an example, but then things will be clearer. But the way you read the table for now is, I'm going to repeat again, the first column and the first row is the Z score, and the body gives us the area to the left of that Z score under the standard normal curve, all right? For example, let's look at this picture over here. So this is the standard normal distribution curve. Let's say you have given a Z score, right? So let's say this is Z. So the table gives you the area to the left of that given Z score, okay? So we have the table for positive Z values like this. Sorry, we have for negative Z values, also for positive Z values as well, okay? So that's the normal distribution table. So we are going to use this table to do the math, all right? Okay, so from now on, what we are going to do is we are going to convert the regular normal distribution to standard normal distribution, and then we are going to use this table to find the area to the left of a specific Z score. Okay, move forward. Yeah, so what I have told you on the last slide, it's written here. So the table gives the area under the standard normal curve for values to the left of a specified Z score Z, which is shown in the figure. So you see, this is the standard normal distribution. The mean is 0, and this is the Z-axis. So if they give you a specific Z value, the area on to the left of that Z score comes from the table. So this area comes from the table. Okay, a very important thing to remember is that the table only gives you the area to the left of that Z score, not to the right, all right? So this is a very important thing to remember. Let's start our first example. A pediatrician obtains the heights of her 3-year-old female patients. The heights are approximately normally distributed with mean 38.72 inches and a standard deviation 3.17 inches. Use the normal model to determine the proportion of the 3-year-old females that have a height less than 35 inches. So let me highlight the parts whose are important. So we are going to find the proportion of 3-year-old female whose height is less than 35 inches, okay? And the min is given by 38.72. So the mu is this, and the sigma is 3.17, and x is 35. So 35, this is basically our x. Now, I always prefer to draw the picture first so that things will be more tangible for you. So let's draw the picture and shade the area under the normal curve that they are talking about, okay? So this is the regular normal distribution they're talking about. The min is 38.72, so that would be in the middle. And they ask us to find the proportion that is less than 35 inches. Remember, guys, the proportion basically tells, the proportion is basically exactly the area under the normal curve and to the left of 35, okay? Because they're talking about less than 35 inches. That means they are asking us to find the area to the left of 35. So they're asking to find out the area to the left of 35 under the normal curve, okay? So let me put a question mark here. All right? So we need to find the area to the left of that 35. Now, what we are going to do is, since we don't know the area for a regular normal distribution, but we know the area for a standard normal distribution from the table. So to use the table, first of all, we need to make the conversion. So let's do that. So let's do the simple conversion over here. So z equals to x minus mu over sigma. So x is 35 minus mu is 38.72 over sigma is 3.17. So the z value over here we are getting is negative 1.17, okay? Now when we convert, when we make the conversion, the picture becomes the standard normal distribution, okay, with mean 0 and standard deviation 1, right? Now, the z value, the corresponding z value over here is negative 1.17. So negative 1.17. So we are going to find out the area to the left of negative 1.17. All right? Because the area over here to the left, finding the area over here to the left of 35 is exactly same as finding the area over here to the left of negative 1.17, right? Because we made the conversion. So basically, we are going to use the table to find the area to the left of negative 1.17. So you look at the table. So you find z equals to negative 1.17 and find the area on the body of the table. So if you look at the table, the area you can find is 0.1210, right? Since they ask us to the proportion, so you make this a percentage. So when you convert this to a percentage, the final answer would be 12.10%. Okay, that's the thing. All right, let's play with the table. So you can go to MyMathLab, go to your homeworks, or go to MyMathLab, and there you can find e-text. Okay, so the e-textbook of your textbook. So you click on the e-textbook and go to the last chapter or appendix of that book, and you can find that table. So that is called table 5. And if I give you any problem in the test which you have to where you have to use the z table, then I will of course provide you the table. Okay, but yeah, this table is very important, and from now you just need to find out the numbers, the exact numbers from the table you need. Okay, so let's work out some other examples here. So let's play with our table, the standard normal table. I hope you found the table already from your book, e-textbook. Okay, so we are going to do 3 examples. This is the left of, we are going to find the areas actually. First, we are going to find the area to the left of z equals to negative 0.56. And then we're going to find the area to the right of z equals to 2.4. And then we're going to find the area between z equals to negative 1 and z equals to positive 1. Right? Okay, let's do it. I'm going to change the last example to 1.7. So z equal to positive 1 and z equals to negative 1 and z equals to 1.7. Okay, that will make it more understandable. All right, okay, first one, find the area to the left of z equals to negative 0.56. Now you go to the table, look at the first column and first row, and adding the first column and first row, you need to make negative 0.56. So let me write it. So in the first column, so you look for negative 0.5 in the first column, and then in the first row you look for 0.06. Okay, because that 2 number adds to negative 0.56. And then you look at the body. The intersection of these 2 column and row is basically the area to the left of z. Okay, so when you find the area in the table, it's going to be 0.2877. What's next? Next one is to find the area to the right of z equals to 2.4. Okay, all right, so let me draw the picture first for this, because I believe picture is will be better for this one. Second one, so they're asking us to find the area to the right of z equals to 2.4. So this is 0, the standard normal distribution. So 2.4 should be on the right of 0, right? So they're asking us to find the area to the right of 2.4. Okay, now you go back to the table, search for z equals to 2.4, find out the 2.4. What is the area for that? So if I look at the table, the area is going to be 0.9918 from the table. But remember guys, the z table only gives us the area to the left of some number, not to the right. That's why this is actually wrong, because they ask us to find the area to the right, not the left. The table gives us the area to the left. So the table gives us this part, which is 0.9918. That is from the table. Now, since we know how much is on the left, how do we find how much is on the right? You have to use your common sense, guys. I told you that the whole area under this curve and above the x-axis, the whole area is 1, right? Since the left side is this 0.9918, so the right side of 2.4 should be 1 minus the left side. So it's going to be, the right side is going to be 1 minus 0.9918, which is 0.0082. So it's going to be 0.0082, all right? So when you're going to find the area to the right of some z-score, you find the area to the left from the table, and then you subtract that from 1 to find out the right. Okay, cool. Let's talk about the last one, which is to find the area between z equals to -1 and z equals to positive 1.7. Okay, let's draw the picture. Let's draw the table, and things will be better with the picture. Okay, sorry. So this is 0. -1 should be on the left, and positive 1.7 should be here, right? So they are asking us to find the area in between. So what is this part? Okay, now what we are going to do is we're going to find what is on the left of 1.7 using the table, okay? And then we're going to subtract what is on the left of -1, right? So that's the thing. So go back to the table. From when z equals to positive 1.7, the area to the left of that z-score is 0.9554 from the table. So this guy over here is basically the area to the left of 1.7 all the way through to the left end, right? Okay, now the area for -1 from the table is 0.1587. Okay, so this 0.1587 is the area to the left of -1, which is this part. Okay, so what we're going to do is we're going to subtract the bigger portion minus the smaller portion, because that will give us the middle portion, right? So that's the thing. So the area between those two z-scores is between them is going to be 0.9554 minus 0.1587, which is 0.7967. Okay, so that is basically the answer. So let me use a different color because I have already put 1.7 here. So the answer is going to be 0.7967. Okay, all right, let's stop right here, and we're going to continue this in our next class. Thank you, guys. I'll see you very soon.